Welcome to the August meeting of the Royal Astronomical Society of Canada. Do we have any people new to astronomy here, or people who aren't members? I'd like to know that you're welcome. Tonight we have a program of astronomy for observers, astronomy for armchair astronomers, and astronomy perhaps for people who are new to astronomy. Is this working? Could we go to the table of contents, please? Okay, first up is Robert Alexander. This is his first time on stage. He's going to talk to us about what things there are to observe in the sky for the month of August.
Well, actually, it's my first time on stage in your tenure.
Okay, that's all that counts.
There we go. This month, we have the pleasure of having the great god Jove prominent in the sky all month. And he comes to us manifesting as the planet Jupiter. Jupiter is very prominent in the south, rising about 8:30 in the evening and setting about 3 in the morning. For the next, on the 14th, Jupiter reaches its transit, its highest point in the sky, almost due south, at about 1 in the morning. But any night is good. If you happened to look up at the full moon last night, you would have noticed a very bright light just below and to the right of the moon, and that was Jupiter. There is an interesting occurrence on Jupiter right now, which Rolf is going to speak about later, and that's that we had an impact with Jupiter last month. An object went plowing into the cloud tops of Jupiter towards the South Pole. That appears on the top on this shot. So south is up here, but you can see the circled area there, which shows the scar in the cloud tops, which is starting to stretch out with the motion of the clouds. Rolf will speak more about that. It's quite interesting. You can also see Saturn right now just before the sun sets. It'll be quite bright in the west. There was an eclipse on Wednesday night, but don't worry, you didn't miss anything. You couldn't have seen it. The moon passed barely through a piece of the Earth's shadow, still mostly lit by the moon, but it was technically an eclipse. It happened just after sunset. On the 9th and the 11th, now this is not something that you're going to see, but just something that is interesting and quite personally interesting for me, because I'm quite interested in the moons of Saturn. The Saturn Cassini probe will be doing a very close flyby of Titan in a couple days, 970 kilometers from the surface, so that's quite close. And on the 11th, they've scheduled yet another flyby of Enceladus, and Enceladus, of course, is a very interesting moon. They've discovered that it's jetting out water vapor and other gases, and it's quite fascinating. On the 11th and the 12th is the Perseid meteor shower, which unfortunately will be accompanied by quite a bright moon, but Pierre will be talking more about that tonight. On the morning of August the 14th, just before dawn, if you happen to be up, you can see the moon making its way right through the Pleiades cluster, and it will actually block out some of the stars in the Pleiades cluster. So quite an interesting occurrence to watch for. And yeah, that's just before dawn, starting about an hour before dawn on the 14th. The 17th, we have Neptune also in the sky, and it's at opposition, which is its best point to be seen. It's where it'll be its brightest and relatively closest to us, though it's very far away. On the left-hand image here, this is if you were looking up from the ground, and you can see there's Jupiter. Jupiter is going to be very, very easy to see, and you can see that Neptune is quite close. It's about 3.5 degrees from Jupiter, about 3.5 degrees east. And it can be found if you look at the other larger image here. This is what you're going to see in a telescope, and it forms just about a right angle with the star there. And so yeah, it shouldn't be too hard to find, and will show a noticeably blue disk in a medium amateur scope. Here's also the planet Uranus is going to be visible in about the same area. It's in Pisces, and if you want to find it, I would recommend you look at a star chart. I don't have full details here on spotting it, but you can see it's kind of in a line with Jupiter and Neptune. And here's a closer view as it relates to these various stars in Pisces. And here on the left is an image from starry night of the planet itself with 5 of its moons. And that is also how it appears at 11 p.m. on August 17th, and that is the actual arrangement of the moons at that moment as well, at the moment of opposition. August 26th, we have an interesting occurrence with 2 of Jupiter's moons passing in front of the planet and casting their shadows upon the cloud tops. And so we will have both Europa and Ganymede will be passing in front of Jupiter. Ganymede will be there first. Europa joins Ganymede at 10:41 in the evening, so about 20 to 11. By 11:30, both Europa and Ganymede's shadows are well visible on the disk. The trick will be to look for the disks of the moons themselves, not just for their shadows. And it'll take an hour for the pair to traverse. At least there will be 2 shadows visible for about an hour after that, until about 12:30 in the morning on the 27th. So that's something to watch for if we got clear skies. One of the constellations of interest this month, visible in the south, fairly low to the horizon, a little, but we're rising enough above the horizon to be enjoyable to look at, is Scorpius. On the left, you see the star chart for it. On the right is an actual photograph. The prominent star in Scorpius, of course, is the massive red giant Antares, which is that one right there. Antares is so big that the disk of if it were in our solar system, the surface of that sun would be between the orbits of Mars and Jupiter. It's enormously big. It's about 800 times the physical size, the diameter of our sun. So there's some great Messier objects as well. We have EM4 and M80. There's M4 right there. Messier 7 and Messier 6 are also part of Scorpius, and we'll touch on those very briefly. EM4 is a globular cluster. That's the one we were just looking at there, and here's a photograph of it. It's quite easy to see. You can see this with binoculars. It'll appear as a fuzzball with binoculars. On a really clear night, really clear, very dark night, you can pick it out with the naked eye. It's not a big cluster, but it's relatively close. It's 7,200 light years. Definitely worth seeing. I personally love globular clusters, and I think they're one of the prettiest things in the sky. M80 is between Alpha and Beta Scorpii, Alpha being Antares, and so it's right halfway between there on that line. It's quite ancient and very far away at 32,500 light years, and it's a city of several 100,000 stars, with quite a few secondary blue giants. Anyway, M7 down towards the other end, right opposite this pair of stars here, which is quite prominent in Scorpio, often referred to as the cat's eyes, and they kind of point towards M7. This is an open cluster, so it's not a densely packed globular cluster like the other ones. It's more of it's a looser association of stars. About 80 stars, quite easily detectable with the naked eye, and with good dark skies. About 800 to 1,000 light years away and about 220 million years old, so as clusters go, it's quite young. And this is definitely worth taking a look at. We also have the butterfly cluster, which is just up a bit from M7 there. Called so because of its sort of if you squint your eyes, it kind of vaguely resembles the shape of a butterfly. And once again, about 80 stars in this one as well, a little further away than M7, but not much, and between 50 and 100 million years old, so also quite young. I know it's odd to speak about millions of years as being young. The other constellation of interest is Hercules, which is quite easy to spot. You're going to be looking pretty much straight up. You'll spot Vega, which is quite bright overhead, and you will see, quite easy to see, even from downtown Ottawa, you can see the summer triangle of Vega, Deneb, and Altair. And just off the line between Deneb and Vega, with just slightly dark skies, you'll be able to see this quadrangle here, which is commonly referred to as the keystone. Keystone being the asterism that's part of the constellation Hercules. And we have two very nice globular clusters in Hercules. M13 here, the Hercules cluster, and M92. And here's a little closer look at the keystone. You can get an idea of where they are. So this one, M13, you can spot with the naked eye on a good dark night, and it's just gorgeous in even a small scope or binoculars. And here's a shot of M13. When I was putting this presentation together, I also had a shot of M13 that was a Hubble shot. This is a smaller telescope here, and this is closer to what we'll see. But the Hubble shot was stunning. There was just so many stars. And it's interesting, I read in the description on this online, because I did a little looking up, and I found one quite authoritative seeming website, very scientific website, claiming that the age of M13 was about 16 billion years old. And I thought, well, gee, that's really old. As a matter of fact, that's about 3 and change billion years older than the universe itself. So I figured they must have had their figures a little wrong. So I'm just saying over 10 billion is very old, very old. Several 100,000 stars and about 25,000 light years away. Quite large in diameter, 145 light years in diameter. This is a big object, E in our galaxy. And finally, we also have EM92. It's about the same distance away. Again, they had an age estimate of it that was larger than the current estimate of the age of the universe. So I just said over 10 billion, and once again, several 100,000 stars. And it truly is a stunning object to see. Now, this month, we've had, this last more than a month, it's rained, in case you hadn't noticed. It's been mostly cloudy as well. We've had little moments of clear skies, and but it's just, heaven forbid we should have a day without rain. My sump pump has been coming on. It only ever comes on in the spring. But anyways, you think our weather is bad and has cloud. Here's what's happening on Jupiter every day. This is speeded up, of course, but just as an example of a totally violent and active weather pattern. And I'll leave you with that thought. Thank you.
Thank you, Rob.
You're welcome.
August is cottage month, and
Actually, I
I'm
should
sure a
put
lot
that
of
here,
your
it's
non-astronomer friends have told you stories about how they love to go out on the end of the dock and launch, or not just look up at the sky.
Oh,
and
here,
say,
you
"Oh,
want
should we
to
start?"
switch to something
But
else?
of course, it's the Perseid meteor shower. Contrary to popular belief, it's not the most intense meteor shower during the year. The most intense is possibly quite intense, but the Perseids are the most comfortable meteor shower. And this year they may be the most interesting for reasons that Pierre Martin, the most active meteor observer I know, is about to explain.
Okay, just a second.
Okay.
There it is.
Okay, great. Okay, so the Perseids are arguably the most observed of all meteor showers, and for a good reason. They are plentiful, colorful, and bright, and they occasionally throw out a nice fireball. And it just happens to be a time of the year when people are often out on their vacations, and just nice to be able to enjoy the nice clear nights. Hopefully we'll get some more of those. And it's generally a comfortable time of the year to observe. The bad news, obviously, this year is the moon is going to be in its gibbous phase right on the peak of the night. So there will be no escaping the glare of the moonlight. So that will definitely diminish the Perseid activity. But there is some good news to maybe look forward to, and that is that we might actually be looking at a particularly impressive activity this year. And I will explain a bit more on this a bit later. So basically what you have seen in the publications, oh, there we go. Okay, it's what they're telling is the moonlight will definitely spoil the view of the meteor shower, significantly reducing the visible meteor count, which is true.
Pierre?
Yes, go ahead.
How far back are there reports have you read about the people observing the Perseids?
How far back?
Yeah.
Going back in history, I would say that the Leonid meteor shower was what really set off serious meteor observations, going back into the last century, or I should say the 19th century. And the Perseids were discovered not too long after that, when people started scanning the sky looking for more showers beside the Leonids, back in the early, or I would say the late 1800s. So the last time the comet Swift-Tuttle, that's the parent comet of the Perseids, was seen was in 1992. And it was met with some very active display because there was a large concentration of dust in that area. The previous occurrence in, I believe, was 1862. As far as I know, we don't have any official records of what was seen, but it is assumed that there could have been possibly some near storm activity in it.
So is there any noticeable trend in the counts, in the hour counts from one year to the next?
Yes, there is. There is definitely a pattern. I was going to mention that in a while, but briefly, the two major planets, Saturn and Jupiter, actually cause an influence on the Perseid dust stream in space. So whenever Jupiter or Saturn approach the dust stream, it actually causes a gravitational shift, which brings the core, the dense dusty core of the Perseids, closer to the Earth intersection point. So every few years or so, we actually see an above average display. This has occurred in the early 80s. In the early 90s, in combination with the return of Swift-Tuttle, which gave us some very active displays. It last occurred in 2004 when Jupiter gave the stream a bit of a push, and it's due to happen again this year. So we're certainly looking forward to some pretty impressive displays.
Yeah, I heard there was some prediction of high counts for this year.
That's right, yeah. So we're still about half the screen.
So you're a member of the, are you a member of the North America Meteor Network?
Yes, I am part of the NOM, the North American Meteor Network. So that's like the clearinghouse, so to speak, for North America, as well as the International Meteor Organization, which collects data from amateurs and also from different groups such as the NOM, and brings all that data, all those reports into one big database. And once in a while, the IMO will use that data to create a global profile, a study on the meteor shower to determine the peak level and determine if there's any secondary activity. So we can actually learn a lot from using all the data that's been accumulated. Question over there?
Yeah, we know that you like to travel to meteor showers. What's the farthest you've driven to?
The farthest I've driven to, not flown to, but driven, and that would be Central Tennessee during the 2006 Geminids. That was a last minute trip that I decided to take because Ottawa and even the whole area all around the Great Lakes was completely clouded out, and I really didn't want to miss that year for the Geminids because it was going to be a good display, new moon conditions. That was back in 2006. So the closest area for solid clear skies, according to the clear sky clock back then, was Central Tennessee. And I figured, okay, I'll bite the bullet and just head off and hope for the best. And it turned out to work out beautifully.
That was worth the trip.
It was. I was able to see several hundred meteors throughout the span of a few hours in a night.
Any speeding tickets?
No, not quite, but I came close.
Here, there was a report of a possible meteor impact here in the Ottawa River recently.
Oh, yes.
Some people had thought it was an airplane, some people thought it could have been an impact.
Yes, that's right.
Do you have information on that?
Well, I finally caught up on that just recently, a few days ago. I was a bit out of the news. So I was reading all the various reports, and I know there's been a lot of speculation as to what it could be. Someone who set off fireworks or meteorite, something. People claim that they saw something go down into the water. Personally, I know that night was a clear sky, and it was also the peak of the Delta Aquarids and some other minor showers. So I would not discount the possibility that it could have been simply maybe a bright fireball, maybe one of the bright Capricornids that at that time of the night would appear to drop straight down to the horizon if seen into the western sky, which was the case because it was where people were gazing over the rapids. So if a meteor was really bright, it can give the impression that it was a lot closer than what it actually was. And who knows if maybe that set people's imagination off, thinking that they saw something go down, when in fact it might have been much further away. But again, I don't have any concluding information aside from there's been a lot of searching and nobody was able to find anything in the bottom of the river. Yeah, we have anything?
For now, this is the best we can do, so I suggest you use what you can.
Oh, okay. Well, no, that's fine. We'll go with that. Okay, so I'll just continue on where we were. So the third point, why bother? Just wait until next year. That was another reference that I caught. Well, I think we have a lot of reasons why we should bother. I know the moon's going to be very bright and definitely spoil some of the display. But the Perseids could be impressive, and I'll get back to that in more details in a bit. So we'll go on to the next slide, please. So now we're looking at the midnight sky on Tuesday, August 11, facing east. So we can see a little bit what's going on. So if you look, let's get this going. Down here, this is where the moon is located. So it's fairly low in the sky by that time, but still definitely going to be up all night. So there'll be no escaping the moonlight. The meteors by that time are going to appear mostly to shoot upwards in every part of the sky, but trace back to the radiant, which is located at northern Perseus. I think just a degree or two to the famous double cluster. Next slide. Next slide, we're looking now at the pre-dawn sky that same night. So on Wednesday morning coming up, the radiant is going to be almost straight up. So by that time, you're going to see the meteors coming out in every direction, mainly shooting down towards the different horizons. And here's the moon. It's going to be very high up, and it's going to be up high over the southeast. So we're going to look at the next slide now. The other bit of good news is if we do get clouded out on the first night, there's a chance for some enhanced activity also on the morning of the 13th. So that could be an interesting night to keep an eye for sure. So here we have the pre-dawn sky on Thursday morning. You can see the moon is starting to wane into the third quarter, but it's still going to cast a lot of light, a major glare into that part of the sky. Next slide, please. And here we have the pre-dawn sky. What I would suggest is this is exactly the same time of the night, but notice the moon is out of the way. So because we're facing the northern horizon, this is what I would recommend that you try to do. You will not see the radiant directly in your field of view. It's going to be up sort of just off the corner of your eye. But this will allow to keep the moon away, which you'll see the meters dropping down towards the horizon here, which will give you a better view. And it's actually better to not look too close to the radiant, because meteors in that area tend to be very short path because of the perspective, and the ones flying further out will produce nice long trails, which will make them easier to see. Next slide. Okay, so speaking about the shower's radiant, what this is really is just an effect of perspective. So if you were an observer standing right here and looking out in space, and you'd see the meteors coming from the same shower, they would appear to be moving in parallel paths. Now in reality, the meteors burn up in the atmosphere a lot closer to us, so this is an exaggerated view. And the screen that you see is just an example. There's no real screen. It's just to show you if you would project the meteors onto a flat surface, they would actually seem to be coming out of a one point which is called a radiant. And we call the Perseids this name because the meteors come from Perseus, just like the Geminids would come out of Gemini. Next slide, please. Okay, now here, on this illustration, we see several meteors that are by the arrows. And there's a constellation Perseus with our radiant right here, and the bright star Algol, and the W of Cassiopeia. Out of all these meteors, there's only one that can be called a Perseid. And the reason for that is there's a criteria. It's not simply that the meteors must come out of the radiant, but there's a second criteria that to be called a Perseid, the area between the radiant and the beginning of the meteor must be at least twice the distance of the meteor's length. So keeping this in mind, the only meteor that can actually be called a Perseid here is this one right here, because the distance between the radiant and the beginning is at least twice as the meteor's length itself. So all the other meteors are either sporadics or part of other minor showers which are also active. So chances are if you're out looking for Perseids, you will see some of the other activity that are coming from different direction in the sky. Okay, next slide, please. So in the past few years, forecasting meteors has been getting better and better, and this is because we're starting to gain a better. Oh, thank you.
No, it didn't work.
Oh, right on. Okay.
Sorry about.
Okay.
Something.
Yeah, we're fine with that. Not a problem. Basically, we're getting a better and better understanding of meteoroids, meteor showers, and meteors, and how they evolve over time. And also, what's also helping in creating computer simulations is also processing power in computers themselves. We're able to use that to our advantage and really get some better predictions, or at least we hope. So there's three main factors that determine how we can, or that allow us to predict future meteor activity. First, we have to know the parent comet that causes the shower, and we have to understand its orbit and how many times it visited the sun. We then have to have a good understanding of when and how quickly those dust grains were ejected from the comet when the comet was near the sun. And that will affect where these particles of dust will be in space. And also over time, the distribution and evolvement of meteoroid streams will depend on other forces such as radiation from the sun, and also the gravitational effects from the major planets that will change how the stream will, and it'll create some clumps of dust higher concentrations of dust in different areas of the dust stream. So by knowing that, we can actually come up with hopefully a better forecast of what the meteor stream is going to produce. So next slide, please. Here we have the computer simulation from one meteor expert, Jeremy Robillon of Caltech. This shows his computer model for the Perseids of 2008 and 2009, this year. And you notice this here represents the clump or the concentration of dust from Swift Tuttle and how the Earth moves in its orbit along it. And you can see that clearly last week we passed quite close to the core of the dust stream, but we actually just barely missed it. Well, this year, thanks to a gravitational push by Saturn, the Perseid stream is really right into an Earth intersection, or so the computer model seems to indicate that very well. So by looking at that, we can actually map out the activity quite nicely, where on August 12th, which is about right here, we're going to see probably some fairly significant activity. And there is, the latest prediction is that between the hours of 4 and 5 o'clock in the morning on Wednesday, August 12th, there could be an outburst of as high as 200 meters per hour. That's on the zenith hourly rate scale. So obviously with the bright moon, we will not see that number. It will be reduced, but even a fraction of that number should be quite good. Then if you look a little bit, this is maybe a bit small for those of you in the back to see, but you'll see there's another clump of dust right here. This will, if it happens, this would fall onto the morning of August 13th. So the Thursday morning, sometime between 2 and 4 a.m., we could get another enhancement of activity. How much for that one, I don't know. I haven't seen a prediction, but it's certainly a possibility. So to keep in mind, both nights, August 12 and 13, I should say those mornings, could provide a good Perseid display despite the moon. Next slide, please. Okay, so another technique to verify if the computer model and forecasts are actually working is to look back at a couple of past showers to see if the predictions have panned out. So here we have the 2004 Perseids, and that year was predicted to be influenced by the gravity of Jupiter that pulled the stream's core into the Earth's path. And as it turned out, it wasn't above average display. All around the world, they reported rates of over 150 per hour, and this was a good year under new moon conditions. Next slide, please. Now, we'll look more recently, just last year, what happened. And since we were supposed to be just on the edge of the main activity of the Perseids, and as it turns out, there was some elevated activity. There was this new filament right here, which surged briefly to a rate of about 120 per hour. This was well seen over Europe, with accompanied by a good number of fireballs. If this filament reoccurs, it would actually coincide with that early morning timing on August 13th, so on Thursday morning between 2 and 4 a.m. So this would fall under our nighttime hours. Next slide, please. Thank you. So just a summary of what to expect. Notable activity is expected over the entire night of August 12th. This is due to the background activity. Possible outbursts during that last hour before dawn. The usual maximum is predicted in the mid-afternoon, August 12th, but this is just the annual background, which is typically only about 80 per hour. And then, as I was mentioning, this other possible feature on August 13, which we should definitely keep an eye on in case it happens. Next slide, please. Of course, with an increase in meteor rates, there comes the possibility that we could see more fireballs than usual. And fireballs will definitely be seen easily even with the moonlight. So this is one thing with the Perseids, is that moon or no moon, there will likely be something to see. This one that was lucky enough to photograph was probably about a magnitude -6 fireball. So with a good night of observing and even spending a couple of hours out during those good times when we should get the enhancements, a good chance that you might see one or two of these large fireballs. Next slide, please. Okay, so observing meteors is actually very, very easy. Just a few tips. You can see the equipment required is actually pretty low tech. Just get yourself comfortable. Bring out a lawn chair, a good sleeping bag. Make sure you do dress warm because the August nights do tend to dip down quite cool now. And just make sure you have everything you need, red flashlight, warm clothes. Ensure that you're well rested. There's a couple of different strategies is what I tend to like to do, especially on the maximum nights of showers, is I just start observing right after the sun goes down, as soon as it gets dark, and continue right up until dawn. But if that's a lot to do, or there's other commitments, set your alarm for maybe about 3 o'clock in the morning, and this way, when you get up, you'll have a shot at seeing the highest number of Perseids. But the Perseids is one of those showers that you can start to view right after dark. Because the radiance is going to be low in the sky, and after the sun goes down, you will not see many, but one thing you can see, and that can be well worthwhile, is earth grazers. Those are the Perseids that you will see coming towards you from the slide. So these meteors can be some of the most spectacular that you will ever see, sometimes crossing the entire sky or 3/4 of the sky, and it can be just beautiful. Just seeing 1 or 2 of these in an hour can really be unforgettable. So to see those earth grazers, the time to look would be between 9:30 and 10:30. As soon as it starts getting dark, even in the twilight conditions, start looking right away, and that'll be your best shot at it. And then as the night progresses, the earth grazers will disappear, and the meteors will increase in rates. However, they will become shorter and shorter as the night goes on, as you start seeing them more head-on, closer to the radiant, as the radiant comes up higher in the sky. So I would say, just to conclude that, just one more slide, please. Just one more point I want to bring is you may wish to try to photograph the Perseids. Traditionally, the photographing meteors requires a lot of luck, patience, and persistence. However, in recent years, the advent of digital SLR cameras have really made things a whole lot easier especially for meteor shots, where you can use one of these timer remote controllers, like the one you see pictured here, and just set in a number of exposures in your camera. So the camera basically does all the exposures automatically without you having to depress the shutter constantly. So the advice would be to use the widest possible angle lens, set to maximum aperture. F2.8 or faster is best. Use the highest ISO that the sky conditions will allow, and the longest exposure, again, that the sky will allow. So obviously with a bright moon in the sky, that will limit the length of the exposure. So you should really try to experiment to try to get the best setting, and ensure that your image doesn't get washed out by the bright sky. And then it's really just a matter of luck to hopefully, as soon as you see a bright meteor scooting by your camera's field of view, just stop your exposure, or make sure that you take a note of which of the time and the exposure you were taking, so you can look at it, look for it later on. So to conclude, I would say that this year, despite the moonlight, it's worth a shot at looking for the Perseids, only because there's a probability that they could be quite interesting to look. Before I left work today, I was just looking at the weather forecast, and at least on the long range, it's looking good. So fingers crossed that Tuesday and Wednesday nights are going to be like that. And also, one more point is we might not see the Perseids as active as we're going to get them this year until 2016. And 2016 is going to be the next time that the major planet is going to push the core of the stream into the Earth's orbit. So good luck, and I hope to hear from your observations later on. Thank you. We have a question? So.
Yeah. How long have you been a meteor observer?
How long? Oh, I would say since I saw my first fireball at 9 years old. Officially, I've been recording meteors for the International Meteor Organization since 1994.
Is that NAMN?
I'm sorry.
What's the name of that organization?
Oh, the NOM, that's the North American Media Network, which as well I've been part of since the mid-90s.
Website?
Here.
Oh, the website, just Google NOM, North American Media Network. And it's actually a really good place to start. They have a lot of handy information, star charts, and basic information on what to look for, a list of the meteor showers, and also they have a link to the worldwide email forum, which is a great resource. This is where a lot of these predictions and top meteor scientists post their predictions on the meteor showers, and you'll find that link on the NOM website.
Thank you very much, Pierre.
You're welcome. Thank
You
you.
want to repeat your whole talk now that you have slides?
I don't think so.
Just like to emphasize, meteor observing is one of those aspects of amateur astronomy where you can do real science in the lawn chair. I mean, you don't get too many opportunities like that. Okay. Next, we have to talk about Jeffrey Coyle, who's going to reenact for us parts of the International Year of Astronomy presentation that he did. It's a multimedia experience with pictures and slides and movies and DVDs. Are you ready to go? And cleverly we fix the video. Jeffrey?
Hi all. This talk is trying to show you some of the flavor of putting on an IYA event. I used somewhat unorthodox media methods and took my bruises. This is actually an outcome of a presentation I made at the end of April for the Gloucester Senior Adult Centre, where I had the audacity to call the presentation a Solar System Odyssey. I had a little movie I made. I had a lot of canned stuff. Very hard to find decent stuff on the internet. I'll try to come to that at the right place in this little show tonight. One of the people who was helping out and saw me doing tests of this material at the Gloucester Senior Adult Centre is connected with a French elementary school in Vars, and he was quite excited about the thing and brought it up to his principal, and I became nominated and accepted an assignment to do a show there. But the first one for Gloucester at the Adult Centre was 1 hour and 45 minutes. I cut, trimmed, and sliced to 45 minutes for these children. But I didn't know initially that I was going to be putting on 4 presentations in the same day. The original booking was for 3, and they sprung a 4th on me. When I got home that night, late that afternoon, I was wiped, I can tell you. So what you're going to see tonight is a little movie that I put together. It's 1 minute and 10 seconds long. It's a bit of a stretch to call it a movie. It's a set of stills, largely of stills, stitched together to a recognizable time track. The kids liked it because I made it particular to their environment, as you'll see. Then this will be followed by the famous to me astronomy2009.org International Year of Astronomy trailer, a simply superb production. Some of you may, I'm sure, have seen it. If you have, it's not a matter of bearing with me, exult in it again. People who have not seen it are in for a rare treat. This will be followed by excerpts from a particular course dealing, well, in part what I'll be showing you deals with Mars, as the title suggests. Most of the material in my first little slide, my first movie, is in French. I couldn't find much French in video stuff, unfortunately. So can we roll? going to see the parts that you're not going to see, so to speak. This is the full presentation. Credits.
For the eyes of the world, now look into space. That's one world step for man. One giant leap for mankind. There seems to be no difficulty in moving around this.
Now I ask you, is that a professional show? It's beautiful. It moves me each time. We're coming now to the heart of the presentation tonight, if we haven't got a glitch running again. I spoke to... Sound's gone.
Volume, Richard?
Okay. When there's no sound, I forgot I had a microphone. This is a bonanza to me, a terrific thing that happened. I was so struggling to get good material to put together my first show like this for April 30th. And on March 2nd, I had deliverance. In the mail came a catalog from a company I'd never heard of called The Teaching Company. And they feature what they call great courses. And lo and behold, there was Understanding the Universe, an Introduction to Astronomy, 2nd edition, with a real classy professor speaking. And I have checked on his background and so on. There's nothing, I can't say too much good about him. His primary areas of research are exploding stars, active galaxies, gamma ray bursts, black holes, and cosmology. and he speaks as fluently in particle physics as he does in special and general relativity. Now, this course was not cheap, but it has 96 lectures on 16 DVDs. Each lecture is 30 minutes, a total of 48 hours of marvelous astronomy. You won't see a thing about exit pupils or speed of telescopes, but you'll learn a tremendous amount of astronomy. I haven't finished it. I'm just delighted to show you a little bit of Mars and Martians that features a trip through Valles Marineris and an explanation of how Mars got its volcanoes.
During its closest approach in 2003, and you can see the two sides of Mars. These two photographs are separated by roughly half a day, and you can see one side on the left here and the other side of Mars on the right. Mars does have a thin atmosphere. It's only about 1% of the thickness of Earth's atmosphere, so 1/100th of atmospheric pressure here on Earth. And it consists mostly of carbon dioxide. 90% of it is carbon dioxide. But because it's such a thin atmosphere, and because Mars is significantly farther from the Sun than Earth is, Mars goes through extreme temperatures, and they're usually pretty low, down from -130 degrees Celsius, so that's 130 degrees below the freezing point of water, up to about 30 degrees Celsius, which is pretty balmy. Okay, that's pretty warm, but that only occurs occasionally near the equator. I mean, you could sit around with shorts and shirts and short sleeve in those kinds of conditions easily, but they don't last long, and they're not over much of the planet's surface. So it's mostly a pretty cold planet, though not in the deep freeze that some planets are in. Though thin, this atmosphere supports ferocious winds, and there are sometimes major dust storms on Mars when the winds kick up the loose dust on the surface. And see two photographs taken on June 26, 2001, when the atmosphere was relatively clear and you could see a lot of details. And then just a few months later, in September, you can see this widespread dust storm that blocked the features from our view. And here in this movie, you can actually see the development of that dust storm over the course of a few weeks and months. You can see how the surface features get covered up or blocked by the dust in the atmosphere. And indeed, a lot of people were worried that the 2003 closest approach would be blocked by the dust. It turned out we got a pretty clear view, so that's good. All right, well, spacecraft have been sent ever since the 1960s, a whole fleet of spacecraft. And the early spacecraft saw craters, volcanoes, canyons, dunes. Since then, we've also seen dust devils, little whirling dust, almost like miniature tornadoes or something like that. Here's one of the photographs that I particularly like. It shows Mars sort of in the crescent phase, which you can see if you're beyond the distance of Mars. We from Earth never get this particular view because we can't see Mars from the backside from Earth. And you can see the polar cap nicely there. But here's Olympus Mons, the greatest volcano on Mars, and it covers an area the size of the state of Arizona here on Earth. And the reason it became so big is that Mars has no plate tectonics because it lost most of its heat long ago. So the plates aren't moving. There's only one single thick crust. And in weak spots of the crust, magma could come up from the interior of Mars. But since those spots didn't move away as the magma came up, the volcano just kept growing and growing and growing over very long periods of time, and it had a chance to become way bigger than Mount Everest here on Earth. On Earth, what happens where there are hot spots is that, as in the case of the volcanoes making up the Hawaiian Islands, the hot spot is there, but the plate is moving across it, so new islands come up in a chain as the hot spot's location relative to the plate changes. And so each of the Hawaiian Islands is pretty big, but not as drastically big as Olympus Mons and the other big volcanoes on Mars. Here's a recent picture of some sand dunes that I particularly like, taken just a few years ago. Beautiful picture of sand dunes. And here are these little dust devils where you can see a little swirling plume of dust going across the desert. Now, the most striking feature on Mars is Valles Marineris, a giant canyon which, if placed in the US, would stretch from one coast to the other. It's just a fantastic place. Another photograph of it. And now I want to show a movie that is based on over 500 high-resolution images from the Mars Odyssey spacecraft, combined with over 50 million laser altitude measurements that can give the topography of this Mariner Valley. So let's play the movie now.
The grandest canyon of all isn't on Earth. It's on the planet Mars, Valles Marineris, or Mariner Valley. This canyon is so long it could stretch 3,000 miles from New York City to Los Angeles, and it's nearly as deep as Mount Everest is high. Lifting off in a cloud of dust, our scout ship heads for Mariner Valley. A swarm of tornado-like dust devils whirls across the mesa, just as in the deserts on Earth. Dodging them, we pass impact craters, where large meteorites violently struck long ago. Dead ahead in our race toward the rim, winds are blowing dust clouds up the valley slopes. Mariner Valley is 10 times longer, 5 times deeper, and 20 times wider than Earth's Grand Canyon. You could drop the entire Los Angeles basin inside with room to spare. The rim stands almost as high above the valley floor as Mount Everest on Earth. Looking westward all along the valley's length, we find giant landslides that tumbled off its steep, rugged walls. On the left lie numerous rocky spurs and narrow gullies formed by slumps and avalanches. After crossing a low ridge, we fly up a tributary side canyon. Inside, the canyon twists and turns in a stream-like way. Geologists think this side canyon was born as groundwater escaped and the surface collapsed. Several more tributary canyons cut into the valley's rim. These also grew where groundwater undermined the surface. The valley walls run far into the distance. Its cliffs and ridges were born through earthquake faulting, the main geologic force that began to open the valley billions of years ago. Tucked into the valley's widest part, Melas Chasma, are many layers of dust, sediments, and rock. Each records a slice of time and fills a few pages in the geological record. Ahead lies a catastrophic landslide that crashed down 15,000 feet and shot debris nearly 100 miles across the valley floor. Beyond the landslide lies a basin containing more layered deposits. These offer glimpses of the past and record part of the valley's complex geological story. Farther into the basin, the floor is covered by hills made of layered sediments whose origin remains a puzzle. Winds blowing for millions of years sculpted the soft ground into long ridges. Turning up a narrow canyon and sailing over a gullied ridge, we fly into Ophir Chasma and find more sediments, wind-carved ridges, and a steep wall with rock rubble heaped at its foot. A long parade of landslides widened the valley, collapsing walls made of hard volcanic rock. A flight through Mariner Valley gives us an exciting glimpse of its geological complexity. Buried in the rocks of this Grand Canyon of all the planets lies a history book of Mars that scientists have just begun to open. One day, perhaps soon, we'll read the full story of this beautiful and spectacular place.
Wow. Well, how would you like to hike around in there, huh? Wouldn't that be a great place to have a whole network of trails?
Well, there you've seen it. I wish the audio had been better. I don't mean that in any pointed way, but this guy is really entertaining and animated. And he's a professor of astronomy. I didn't say this at University of California at Berkeley. And his accolades, his distinctions, his prizes, his prizes for teaching and mentoring are just unreal. And I find, you'll see me in a photo here in a moment, I have developed, I think, a little bit of his gesticulation habits. We didn't have much time to see much of him here just now. So next I would like to show you some audience reaction. There were 4 groups of students of various grades up to grade 8. The youngest were in kindergarten. This is an older group. You can see sort of rapt attention.
Microphone.
These,
You lost the microphone.
I'm sorry, carried away. These are sort of the rewards. It was nice to see the reaction of these children. And although I had staff people there helping with translation because I couldn't have handled it, most of them were quite fluent in English. I would say just about all of them. And the senior grades were capable of reading English in an excellent fashion. Could I have the next, please? Now, in this one, you see a partial image and rather blurry, as I see it, because the projector here broke down. It couldn't handle the material properly, and we switched after a great deal of trouble to another projector and managed to make the thing go. So these are the travails. Flip charts are more reliable if lower tech. May I have the next, please? I particularly want you to meet this young student. I'll talk to him. I'll talk more about him in just a moment when you see him closer up. And you see the difference in intensity. and there's the presenter full on, kind of frontal view. The next, please. Now this young man, at an intermission, one of the forced intermissions because of our technical breakdown, came up to me and asked if he could sit beside me because he so enjoyed the material and wanted to go on enjoying it. And his classmates sitting near him were too noisy. Now, is that not something? So he came up here. Here's the guy doing the gesturing, as I said. Next, please. And here I'm still at it. And these children were really sharp. It was impressive. One girl in French, which I'll try to imitate, said, "Quand est-ce que les planètes sont construites?" or words to that effect. And that's a profound thing. How are planets formed? I was taken. I was able to explain it kind of roughly. But I didn't get into formation of planetary systems. I was able to clear a misconception. One of the teachers referred to the size of craters on Mars and said, just imagine, in French, how large the object was to create craters that size. I was able to clear up for him that the objects are much smaller than the final crater. The crater's 10 to 20 times the size of the object. So altogether, it was a nice experience. And the proof is that I've been invited back to give more. And, well, what can I say? I'm glad to show you a little bit of it here tonight. Thank you.
Hi, everyone. Next slide.
Go, guys.
Next slide. I wanted to share with you a really nice card that we received just a couple of weeks ago in our mailbox. It was for an event that was held back in May. It was a Girl Guide event. It was a Pathfinders event. And what I remember from the event was a couple of things. It was Brian McCullough, John Thompson, myself, and two other gentlemen. I feel bad when I forget their names, Fred, and I forgot the last fellow's name. We were all volunteering for that event. Brian did a nice slide presentation and he made a star clock craft. And there was a group of us that were set up outside, and it was this was at a camp that was about 30 minutes west of Perth. And I do remember the mosquitoes were just downright mean, but it was a clear night, and there was about 180 Pathfinders, which were teenage girls. And what came out of the evening was there was a lot of just a lot of thank yous and oohs and ahs and so forth, and then this nice card that came in the mail. So when I saw that, it was really nice to see that, and I wanted to share that with you. Next slide. Okay, we're planning to make a purchase of Galileo scopes. You remember this is one of the special IYA items or articles. And what I'd like to do tonight, I'm going to send out an email to follow up as well, is that we're obviously going to be purchasing some for some outreach events. But if anyone has any interest in coming along in the purchase, let me know. So if last time we talked about this a couple of months ago, there was a few people that sent me emails and said, oh, I'd like to buy 3 or 4 of them and so forth. The price it's just now going up, unfortunately, 10-15%, but it should be around $35 once you factor in taxes and all the various fees and so forth. But from what I heard, a couple of things. I heard the quality overall is quite good, and the packaging is very good. Obviously, it does not come with a mount. But apparently it affixes easily to tripods and so forth. So if you're interested about this, and again, I will follow up with an email, let me know. I'll get the exact price for you, but it's about $35 Canadian.
You just have a show of hands.
Is anyone, just out of curiosity, how many people would be are interested in purchasing some for your own use? So I'm seeing about, wow. I'm seeing quite a few hands there, about 15, 18 hands. Okay, so I'll send out a note, and if you could tell me how many and so forth, then I will tell you the exact price. 2 other things I wanted to mention really quickly here is I received a request from a retirement home on Carling at Broadview. That's sort of where the old health department is, if you're familiar with that area. Or sorry, Richmond and Broadview. And they've asked if we could come and deliver a presentation to their group. So there's no time or date given, and for these kinds of events, when we're approached for something like this, we usually have a lot of latitude in terms of what we want to present and so forth. If you're interested, if you have some time, it sounds like it could be day or night. Let me know, and I'm happy to provide some materials with you on it. Maybe even if my time permits, I can even go with you. So let me know if you want to give this a try. The other thing I want to mention really quickly here, because I don't have much time, I know, is you're going to hear from me in the next week. I am now going to be planning the fall stargazing events. Obviously, so I'm targeting CARP, the CARP library area. Obviously, it's close to the city as a replacement for the Penny's Point that obviously was washed out with the big floodlight there. But it should be better, obviously, with fall being the sun going down sooner and so forth. So hope you can join us, and I'll be letting you know all about the time, date, and location and all that stuff. Okay? Thanks, everyone.
Thank you very much. How many people here remember Comet Hale-Bopp? That was described as a once-in-a-lifetime experience. How about Comet Yakataki? That was also a once-in-a-lifetime experience. How about the Shoemaker-Levy 9 impact on Jupiter? Also a once-in-a-lifetime experience. Wrong. Here's Rolf to explain why.
So this is a segment that, I guess we'll go to the next slide. So this is a segment that will,
Laser? Or is
I
that
think this is one.
Okay.
So this is a segment that I call Amazing Things in Amateur Astronomy. So last month I showed the video of the ISS passing right over top of Venus. So this month is Amazing Things in Amateur Astronomy is this. So on July 19th, I'm just going to read this. July 19th, 1994, fragments JKL of comet Shoemaker-Levy 9 impacted Jupiter. And then amazingly, 15 years later to the day, on July 19th, 2009, an unidentified object impacted Jupiter. See, they said it was, like Attila said this, it was once in a lifetime, but no. So the first observation and discovery of this event was made by Anthony Wesley of Australia. So we have it so poor. You have no idea how poor the observing is in Ottawa. Well, maybe you do, but it's incredibly bad. In Australia, they have it so much better. Jupiter is way up in the sky. It's almost always clear, and for some reason, their seeing is always very good. So anyway, so next slide. So this is what you would call, I guess, the discovery image, and there's this impact, and it looks exactly like those impacts of Shoemaker-Levy 9. And so this fellow in Australia was the first one to observe this. Absolutely amazing, and he actually did spot it when it was first coming around. So it probably impacted Jupiter on the other side, so we couldn't actually see the impact And you know, it's just a matter of what part of the world was this in view for the first time, and so this was the first image of it. And so there's a sort of an enlargement there. And these three spots here, I think these spots may have actually been existing spots. Next slide. So 2 days later was the first opportunity in Ottawa. So this was my image of it, and obviously the seeing not quite as good, but there it is. It's not really, it looks a little like it's maybe enlarged a little bit, but it's really just the seeing has kind of smudged it. So this is, you know, that was quite an eventful week. This was actually, you know, exactly 40 years after the first manned moon mission, and it was also an eclipse of the sun that week. So it was quite an eventful week. Next is, again, another image from Anthony Wesley, July 24th, and quite clearly it's gotten a bit longer. It's starting to get stretched out. And oh yes, I should say his nickname on cloudy nights is, and probably some other boards, is Bird. So people are calling this a bird strike. That's because that's his nickname that he's chosen. So call this a bird strike. And next slide. This is the most recent. Well, there's probably more recent ones now, but this is a fairly recent one, August 3rd, and you can see it's stretched out quite a bit now, and quite a bit fainter. I think this spot is actually just a spot on Jupiter, so the actual impact area is this here. And next slide. So this is a Hubble view. Okay, so you turn the writing right side up. I wanted to keep the writing upside down to make the point that they turn these images upside down. For some reason, okay, so it's lost its impact a little bit, but for some reason they NASA likes to publish their images with north at the top. I have no idea why, because in the telescope everything we see has south at the top. But Chris very kindly turned the writing right side up, so you can't see.
Ralph, I noticed the Australian photo also had it at the top, so the Australian photo was correct. The first one. These are all upside down.
No, right. That's better. No. So the point is that see, when I turned it upside down, I turned this one right side up or upside down. So.
But in Australia, you would see it the same way as you would in the northern hemisphere, right?
No, because the telescope inverts. Well, I see what you're saying, because it's in the southern hemisphere. Yeah, but the point is, though, that it's when you take an image, it's kind of arbitrary, and what people generally do is put.
There's no point disputing this. We'll just have to go to Australia.
Just by convention, amateur views always have south at the top. That's just. I'm pointing out that NASA's convention is to have north at the top. Amateur astronomers' convention is to have south at the top. Okay, so they obviously a lot more detail, and what is the date on this? July 23rd, again 2 days after the impact, and they very quickly reassembled their Jupiter impact team, which they attributed to. So every 15 years, I guess this team gets together. Okay, next slide. Okay, so this raises some questions, of course. So have impacts been observed even before 1994? And so, of course, people are going now through the records, observations and drawings that have been made for hundreds of years. And even before this, it was proposed that somebody identified at least 5 other dark spots that may have been due to impacts. Like Shoemaker-Levy 9, there was actually multiple impacts. So are there any other bodies? Maybe this is something that broke apart through tidal forces, and there may be other bodies still waiting to impact Jupiter. So we should keep watching in any case. When will this happen again? Maybe this 15 years is the best example we have when we've got very good telescopes, but maybe it happens every 10 years, 20 years, who knows? Keep watching. Don't know yet whether it was an asteroid or comet, unknown. And also, has anybody taken any long exposure images in the vicinity of Jupiter before this, so that we could maybe see if there was an asteroid that came by and was responsible for the impact? Yes, that's it.
Thank you very much, Roel.
Just one question. This is something that's really surprised me, is that there's been absolutely no talk that I've seen concerning pre-discovery images
Right.
of an impactor.
Right.
What gives it?
So, I mean, this could be a fairly small asteroid rather than a comet. I mean, even Shoemaker-Levy 9, it was sort of discovered by chance. People don't typically think of seeing bright or observing near a bright object. I mean, Carolyn Shoemaker, when she first spotted the image, thought it may be a reflection of Jupiter.
So you're saying
So-
that being a comet, it was more visible because of the tail? And an asteroid wouldn't be visible?
Well, I think the other thing with asteroids is that there are so many that are being discovered that I think people take weeks or months or maybe even years before they actually can reduce the data and say that, oh, here's a new asteroid, and they have to be observed for a number of observations before any orbit can be determined. Any picture that you take now is long exposure is bound to show many new asteroids. So it may be just a matter of time before it can be identified. Or there's no.
Is there significance to the fact that it's a black object? When JKL landed, they weren't black; they were white and pinkish shades. But this is clearly a black.
Well, the Shoemaker-Levy 9 impacts also made a.
Black, for sure.
Pardon?
I mean, this one is clearly black, whereas others have been other colors.
No, Shoemaker-Levy 9 also made black spots. Yeah, they were somewhat bigger, but they were very, very dark spots. So this is, who knows what happens.
Thank you very much, Roel. We're not quite done with the bird strike yet tonight, but first we're going to have some observation reports. This is the order of the speakers, if you could be ready. First up is Paul Cloninger.
Hi there, everybody. Just sort of following in the vein of Rolf's observations. And just on the question of spotting this thing, it's been estimated that if this thing was an asteroid, it was about maybe 2 or 3 football fields in diameter. So chances of imaging that out by Jupiter are fairly remote. Even with the comet Shoemaker-Levy impact, it was estimated that the largest fragment was about 1 kilometer across. And those impact fragments, the actual scars in Jupiter's atmosphere, were much larger with Shoemaker-Levy. Okay, just a couple of shots here. Nothing too spectacular. I sort of second Rolf's observations. Our observing conditions are pretty bad here. They are our friends in Australia are being treated to about a 65-degree elevation of Jupiter. We're down to about 25. So we're looking through a lot of murky, soupy air. We've only had personally three opportunities to see this thing since it occurred, and the conditions have been pretty dismal. You can see from the images there, again, nothing special, but I did manage to catch this. I wanted to show this to you. The laser on this one, I'm sorry, is, there we go. It's over here. Oh, sorry, I got it wrong. It's on the bottom. Where's the other? Oh, there we go. That's what I'm after. I just need to find the button. There we go. So you can see you can barely see these spots there, but the significant thing is that this was done with a 6-inch telescope. Our friend Anthony in Australia used a 14. I think Rolf, your images were with a 14, which gives you a lot of grasp. But I did actually manage to see this feature on July 21st, a couple of days after the impact, with a 6-inch telescope. Interestingly, I happened to have shot Jupiter about 10 days before the event. Certainly better conditions than these soupy things. This was the area of the impact, and you can see there's no scar visible there. So one of the things I'm hoping to do, we've got a clear sky tonight, and I've talked to the kind folks at the museum here. I'm going to be opening up the 15-inch telescope tonight, and as luck would have it, this object actually transits Jupiter at 10:28 tonight. So with a 15-inch scope, we may see it, but it's going to be very low in elevation, about 16 degrees. So I'm not holding my breath. What I wanted to do is I wanted to show you this image here. We're going to be zooming in on this. This was taken on Monday from Australia. Again, with Anthony's large scope at 70 degrees elevation. What we'll see, if we see anything at all, is a very subtle version of this. So I just wanted to sort of give you an idea of what to look for when we get out there. But I just checked the sky a few minutes ago, and it's looking good. So after the meeting adjourns there, we'll have the dome open. If you want to come out and have a look, and we'll cross our fingers, and we'll see if we can see this thing live. Okay? That's all I got for you.
Thank you, Paul. Next is Eric.
This is my very first observation report. On the morning of July 20th, past, I was stepping out for some air very early in the morning, and I was surprised to see the moon was still there. So I ran back in the house, got a little pocket camera that I had, put it on a tripod, and started snapping away. And I came out with this image, zoomed in all the way. I realized that it wasn't a very good image, but I figured better something than nothing. So I took this picture, and after taking the picture, I watched the moon disappear into the sky, because this was between sunrise and when the moon was rising up. So there was only that brief window where you could actually see it. After that, it disappeared for the rest of the day. Didn't have a chance to see it. July 20th, it's an important day for everyone who remembers the moon landing. And after taking the picture, I thought, what would it be like to be on the moon right now? What would I see in the sky? And at first I thought, oh, it'd be pitch black because we are on the dark side. Then I realized, no, the Earth is full, and you would see this big, beautiful Earth in the sky. And you would probably have enough Earth shine to actually read the plaque on the eagle that says, "Here men from planet Earth landed on the moon." And that's it. Did anyone else take a picture that morning? So I have the only one. Awesome.
Last month's Lunar Observing Challenge was to observe the site of the Apollo 11 space landing, and NASA submitted an observation to us. They submitted a picture of the actual lander.
Yeah.
I thought it was pretty cool. By the way, have a look at this website. They have other pictures of footprints. Usually we require people to come up and present their pictures, but Bob is out traveling looking for better observing spots. And here's his submission for the Apollo 11 landing observation, and he's being very modest. I guess he found a better observing spot. He also took this image of last month's Deep Sky Challenge, which was to observe the dark lane in 102. That's a very thin lane in the center here, which is very difficult to photograph. Apparently, it requires a considerable amount of exposure and astrophotos to pick up. Most pictures will not show it. And next is Gary Boyle.
Good evening, everyone. Well, of course, July 19th was a monumental date. Again, Jupiter got hit. But where my observatory is in south part of Ottawa, Jupiter really doesn't move over the Rouge till about 2 o'clock in the morning. So unfortunately, I have to wait long enough. And to get up for work at 5 a.m. just isn't so. We're all lucky enough, other people, that they get a pretty good horizon to observe any other time. But just this past long weekend, Sunday night, it was a clear night. I was drift lighting my telescope, and just lo and behold, Jupiter came up around 2:30. It was there, and I figured, let's take a look at Jupiter. So first of all, in the finder scope, of course, finder Jupiter, no problem at all, and 2 little dots on one side, two little dots on the other side. So I figured, well, just 4 moons, nothing really to sneeze at. Next slide. But what it really was, to my chagrin, when I was looking at Jupiter, I noticed a little dark spot. And this is about 2 weeks later after the westerly impact, so I'm saying, oh no, what did I find? And that's one thing, is that with all the people observing or photographing Jupiter, an amateur astronomer, Anthony Wesley, found this impact. And it's great. So no matter when you look at an object, look at the object for a while. You might discover something. So with this on my mind, fresh in my mind, a little spot on Jupiter saying, oh no. But then now going to a planetarium software, I noticed that the star, or I thought was a satellite on the bottom, is really 45 Capricorni. And the next slide shows the actual shadow of Io. Next slide. Next slide, please. Thank you, thank you. And I just missed, well, the impact, but I'm sure it wasn't too much of a scar of an impact. I just got it too late. But still, seeing this little dot on Jupiter, thinking that I had all 4 moons, got my heart racing a bit until I found to my chagrin again that it was just really a star. That was in perfect alignment. So again, case in point, if you're going to look at something, never say, oh, it's going to be. We know astronomy is a science. Discoveries are made every day, and we saw by an amateur. If Ralph could have had clear skies that night, we could have called it probably, Impact Meyer, or Meyer's Impact. So always observe, and let's hope we'll find something one night. Thanks.
Thank you, Gary. Deborah? Deborah has a video to show us.
Wait till I'm long gone. Hi. I was going to have Peter come up here and talk, but he's too shy. So I'll do the talking. I wanted to do something more personal for the International Year of Astronomy, and so I threw together a bunch of astrophotography photos to music. And that's nothing unique because you see a lot of this stuff out there on the internet, but what's really unique is the fact that the music is authorized. Because I contacted the record company and they liked the video and gave me a license to use it for the video on YouTube as well as on our website. And most of the images, or a lot of the images, are deep sky images that were taken with the Ceravolo 300 astrograph, Peter's new design. And he did all the acquiring of the images and I did all the processing because he had no interest in processing. And I discovered I really love doing that. It's very challenging, time consuming, it's a lot of work. But not nearly as much work as getting the images, I don't think. My hat's off to anybody that does that sort of thing, because wrestling with mounts and cameras and filter wheels and computers and you name it, it's a tough job, but it's well worth the effort. But a lot of the other images that you're going to see in this video, and there's about 24 of them, it's about a 3.5-minute video, are wide field images, which I really love to do, and some of them are Peter's and some of them are mine. Some of them date back to the mid-90s, they're scanned film images, and there's a little treat of a time-lapse comet Hacky-Tacky in there as well. So if the AV is actually working, hopefully it will, and hope you enjoy.
Next we have a deep sky challenge. No, that's wrong. That's a character from a Pixar movie, I think. So the challenge is Barnard's E, which is a pair of dark nebulae in a very familiar part of the sky. This is the region of Altair, part of the sky we probably look at all the time. The dark nebula is up here. See, it's, if you use your imagination, roughly E-shaped. These are the two dark nebulae, 142 and 143. This is an excellent object for dark sky and binoculars. Quite a challenge for astrophotographers because this is a wide field object and several degrees across. They require a considerable amount of mosaicing. Those who are extremely excited may wish to also look for B334, 336, and 337, which are these fainter dark regions here. And just for those who aren't familiar with dark nebula, these are not regions of low star densities. These are clouds of dust that are seen projected against an extreme dense background of Milky Way stars. Very pretty area of the sky to just look at. Alrighty. Next we have the Lunar Challenge by Brian.
All right, something a little bit different this evening. All right, go to the next one, please. All right, I was just going through my father's coin collection. He knew about it, but and I found this coin. It's from 1979. It's a 10-year anniversary U.S. $1 coin in commemoration of the moon landings 10 years before. The area we're going to be looking at is we saw in some of the images from Peter and Deborah there in the Mare Imbrium Basin. And it's the large craters Archimedes, Autolycus, and Aristillus. And what I've got here is what I'm calling a mixed media challenge. If we go to the next one, please, Chris. All right, here's the area we're going to be looking at. There's Archimedes, Autolycus, and Aristillus on top. And this is the ring here of the Imbrium Basin that was formed 3.8 billion years ago. Now this image, I have to say, is Doug Loma. I borrowed this from a presentation that you did earlier. Lovely series of images that Doug did showing all of the phases of the moon, and he animated them, and it's gorgeous. And I plucked this one out just to highlight Doug's fantastic work on the photography side of things. All right. All right. A fellow by the name of Rich Handy had this image on the lunar photo of the day. So if you Google LPOD, LPOD, and it was for August 2nd, and what he did, he was observing the moon through a telescope, and he took out to the telescope with him an 11-inch by 13-inch sheet of modeling clay. It was only about a 1/4 inch thick. And as he observed, he started adding more clay, building up, pushing things around with a butter knife, spreading things out, shaping what he saw in the eyepiece. And he created this half of what you see here. The next day what he did was he ground up some charcoals, white and black charcoals, and then used a sponge and sponged them into place to add the dark albedo features or to lighten up some of the features here. And if you go and look at a photograph of Aristillus, which is a beautiful impact crater here with lots of nice ejecta rays, have a look at the photograph and compare it to Rich Handy's work that he's done in modeling clay. Now this is a stunning piece of work. Are there any artists here who either work with paints or with modeling clay or anything? I mean, you can even go and crochet what you see at the moon, through the eyepiece. And
is that the challenge?
That's the challenge. What I'll do, but it's got to be mixed media. What I'll have a little something for everybody next month who comes in with something that they've taken from their own observation of the moon, and created using I don't know what materials, but more than one material. So not just pencil and paper. You can use if you're sketching, then add something else to it. I don't know what. Or if you're using, as he did, clay, he worked with modeling clay and he put in the charcoal. All right. And if we go to the next one, this is what inspired him. This was from the classic book, The Moon, Considered as a Planet, a World, and Satellite. And this is a plaster sculpture by Naismith and Carpenter. And this is what inspired Rich Handy to do what he did with clay. So hopefully this will inspire you to do your own. Okay, now just stepping away from this. Okay, we go to the next one, please, Chris. This helps us shift our focus for a moment. All right, let's go to the next one. I was coming back from looking at my father's coin collection in Montreal, stopped at Castleman for, I'll say, a cup of coffee, okay? what do I see tearing out of the parking lot is this truck. And I'm thinking, what on earth? So I whipped lifted the trunk, got the camera out, and took a really fast shot here. Search for it. Okay. I thought it was search for extraterrestrial intelligence. I thought, what kind of yahoos are running around? I hope you're not here, by the way. But it's not search for extraterrestrial. It's search for. I just noticed this when I was putting the presentation together. Search for existing terrestrial intelligence. And I can tell you now, there's none up at this end of the podium, right?
Thank you, Brian. Now, to close the show, a report on big science. Big science, as in billions of dollars of equipment, is Al Scott.
This is an image from the Spitzer Space Telescope pictured on the left. Spitzer is an infrared space telescope, and it's it's actually cryogenically cooled to take infrared pictures in the near infrared and the mid infrared. It's basically imaging heat radiation from the universe, and it's actually this cryogen cools the main detector so that you get a nice dark background. Well, the liquid helium cryogen, or I'm not exactly sure if it was liquid helium or hydrogen, but the first cryogens all boiled off, and so Spitzer's actually now can't use its thermal infrared camera anymore because it's too much noise. It's actually warmed up to around liquid nitrogen temperatures of 77 Kelvin. But this image was taken back while it still had all its cryogen, and this is an image of NGC 1097, which is a barred spiral galaxy, and you can see there's a companion galaxy here, which looks like it's nicely framed in a hole in the arms here, and no one's exactly sure whether that's actually passed through and punched a hole in there or what it is. But this is a false color image. These are infrared wavelengths. The blue color code here corresponds to shortwave infrared or near infrared, and the red color code corresponds to the middle infrared or thermal, more thermal wavelengths. And the interesting thing about this object is that there seems to be an eye in the middle. You can see this eye in the middle, and it's actually this galaxy is 50 million light years away, and the eye is a ring of extremely high star formation rate around a very massive central black hole. The central black hole in this galaxy is estimated to be 100 million solar masses, and that's quite a bit more than our Milky Way's central black hole, which is only a few million suns in terms of its mass. So they think that this is bursting with star formation because of the massive black hole and gas feeding down the bar into the center here. And people don't know that what's going to happen, and will it become a more quiescent black hole like the one at the center of our galaxy in a few million years when the gas is all used up in the galaxy? It's hard to tell. But it's an interesting image, and so now the Spitzer Space Telescope has moved on to its older phase of its mission now that it's lost its really cold cryogens. They're still using it for other observations, but eventually it's going to lose its liquid nitrogen coolant as well, and it's going to warm up to the ambient temperature and won't be of any use at all. So the next one. Closer to home, this is an image of Enceladus, and on the right we see the Cassini spacecraft before it was launched. And the Cassini spacecraft has, there's been recently a paper published, or several papers published on the outflows, and I spoke to you last month about some of the salts that have been detected in the icy geysers that are coming off the surface of this moon, that have been imaged off the surface of the moon. The space probe actually flies through these geysers, and it's got instruments on board. It's got an ion and neutral mass spectrometer, and they've published a recent paper, and it's actually sensing the materials in this vapor, icy vapor coming off of Enceladus. And what they've detected from October 8th last year is ammonia in the ices. And ammonia acts as an antifreeze. In fact, when there's ammonia in water, it can keep the water liquid as low as 176 degrees Kelvin, or minus 143 degrees Fahrenheit, which, I don't, what's that in Celsius? It's about minus 100 Celsius. With enough ammonia. And so what they're thinking is that Enceladus could have an ammonia water ocean underneath this ice underneath a pure ice covering. And this is kind of what they call the holy grail of icy volcanism. And they think that the Saturnian system could be full of these ammonia-type geysers spewing water and replenishing the rings. So just how much water is contained in Enceladus' interior is still up for debate. So far, Cassini has made 5 flybys in Enceladus, and it's one of the chief targets for the extended mission that's ongoing now that it's extended beyond its original mission. 2 more close flybys are scheduled for November of this year, and also for April and May of 2010. And of course, where liquid water exists, there's also the possibility for chemistry that might promote life. There may be the possibility that there could be life in the oceans of Enceladus, although it would be quite cold and probably very simple. Computer models suggest that what happens is that when this forms, there's a mantle of mixed ammonia and water ice, and it's all intermixed and it's just ice. But what happens is that there's a rocky core in there, and as this thing gets tidally stretched by encounters with Jupiter and other moons, heat is generated at the interface between the ice mantle and the rock. And that heat promotes differentiation of the chemicals in the ice, and the ammonia will sink down to the core, and the water ice will differentiate. So you have a pure water ice on the top and a dense ammonia water antifreeze layer between the rocky core and the ice, where you could have an ocean all the way around the moon. So computer models suggest that this is what could be happening. In fact, these tiger stripes that you can see on the planet, and they've detected geysers coming out of these tiger stripes, the thermal infrared measurements tell us that the temperature of these things is similar to the temperature at which ammonia water will be liquid. So that's kind of neat stuff. And the next one. My final news item. A team of astronomers has discovered a group of rare galaxies called the Green Peas, with the help of amateurs working through an online project called Galaxy Zoo. And the finding could lend unique insights into how galaxies form stars in the early atmosphere. This is neat. Galaxy Zoo users volunteer their spare time to help classify galaxies in a big online image bank. And these objects stuck out. There's over 1 million galaxies in this image bank, and of the 1 million, there's approximately 250 of these green peas that have been identified. Obviously, it'd be a very difficult thing to find if you were doing computer searches or not knowing what to expect. So the help of these amateurs have identified these interesting things. And what's really neat about these things is they're among the most extremely active star-forming galaxies ever found. These are at distances on the order of 1.5 to 5 billion light years away. So the light has been redshifted quite a bit from when it was actually emitted. And these galaxies are about 10 times smaller than the Milky Way and 100 times less massive. But they're still forming stars at a rate 10 times faster than the entire Milky Way galaxy. So that's kind of an interesting thing, and nobody really knows why or what these things represent. They're not a large proportion of the known galaxies out there. So they're growing at an incredible rate. It's possible that they would have been normal in the earlier universe. Maybe these are where all the, similar to how globular star clusters and these things may have formed, or proto-galaxies, which then grew by accretion and collision into larger galaxies like the Milky Way and Andromeda that we see in our nearby universe. So it just goes to show that even as amateurs, you can really contribute a lot to the science by helping out on some of these professional projects. And that brings me to the end. Thank you very much.
Two questions. First, for the discovery of ammonia in the water being jetted from Enceladus, that would have to lower our estimate of the temperature of the liquid body that's underneath the icy surface. I mean, before we didn't think there was ammonia there. So does this increase or decrease the chance of there being life in possibly that there might be extremophiles that can live that cold or in the presence of ammonia?
I think it's really unknown at this time. what type of life might exist in an antifreeze type solution at those type of temperatures. Obviously, the chemistry that you're going to expect is going to be relatively slow acting, and maybe there are deep sea thermal vents like you find on Earth where the temperature rises quite a bit. That may be, places where there could be more intense chemistry going on. There may be chances for less extreme extremophiles, but nobody really knows.
Okay. Secondly, the green peas, they're appearing green because they're red shifted from blue.
I expect that's the case, yeah. I think you've probably got a hydrogen alpha line there that's been red shifted a bit.
Thank you very much, Al. One of the things I really like about astronomy is the fact that it is so big. It makes the national debt seem so small. And the emails of our politicians seem microscopic. Okay, so that is the program for this evening, but we have a few announcements. First, tiny bit of center business. First, next year we're looking for a new meeting chair. This is my idea. I remember that ever since I've been here since the early 1980s, every time we've had a new meeting chair, something about the meetings improved. The new meeting chair would always have a new idea of how to do something better. So I think changing meeting chairs is like having a bath. You should have one every year whether or not you need it or not. So if you'd like a job, talk to Paul Harrison, our president, and he'll set you up. Another announcement is we have a new Astronauts editor. It's going to be Deborah Tickner. She's going to take over. She comes back from her 3-week trip to Chile. I presume you're going to the Atacama Desert. Deborah Tickner's right there, by the way.
Sarajevo.
I'm sorry, Sarajevo. It's hard for me to keep track. I understand Deborah's going to one of the best observing sites on the planet, which I personally think is bigger news. My only question for Deborah is how many of us is she taking with her?
Not you, that's for sure.
Well, I don't remember her name. All right. Just after the meeting, we're going to have our carbohydrates and caffeine with Art and Fraser. This is also your chance to argue about whether or not there are extremophiles on which galaxies or which bird spots or Wesley spots are on Jupiter or not. We've also special ordered a clear sky tonight and Jupiter. We couldn't quite arrange for a high altitude for Jupiter, but the 15-inch telescope will be open and many of us will be rushing out. It'll be on the meridian in approximately 20 minutes, which means that we should be able to observe it now, assuming the seeing cooperates. Later tonight, some of us are going to go to Kelsey's for some alcohol and some food and more conversation. And with enough alcohol, even these guys look good. On August 20th to 21st, will be Starfest. For those who don't know, Starfest is the largest star party in Canada. It's a congregation of about 700 astronomy geeks, which means that no matter how crazy you are in astronomy and how out of place you are with your hobby at home or at work, you're right at home here. I've been to Starfest for many years, and sometimes it just poured solidly without a break during the entire star party, and I still had a terrific time. This is, I believe, a 2002 image. My telescope trailer is right there. The RASC members from various centers did the setup in this area. The Ottawa Astronomy Friends did the setup here. I believe there's usually a group of Ottawa people around here, so if you're going, you should look us up. We have a bunch of Starfest brochures contributed by Deborah. Please grab one. Also, for those people not going to Starfest, Mike Earl is having a star party at Bull of Kintail. This is a public event. Feel free to bring your telescope. Contact Earl through his website. The North Kintail, for people who don't know, is the same property as our club's telescope. It's out by Almont, and the skies are reasonably dark for only approximately a 40-minute drive from the west end of town. The next meeting will be in September on the 4th. And finally, I'd like to thank all of you who came tonight, especially Chris, who not only does real-time editing of PowerPoint slides as we're watching the show, but has spent many hours in the background editing slides and jockeying recalcitrant DVDs and videos of work. I'd also like to thank other anonymous people who just showed up today. We show up about an hour before the meeting to get everything working, and that's when we know the equipment. Today, to our complete surprise, there was a new projector, all the microphones were different, and somebody had rewired the panel. So actually, I'm unimpressed that we had a show tonight at all. So big thank you from me to the crew. So big thank you from me to the crew.